Welcome to Vision Plus and welcome back to S.4 Mathematics. We are looking at normals and tangents to curves. Example 1 says, find the equation of the normal and the tangent to the curve y equals to x squared at the point 2 and 4. So the solution to this part A, we have the curve y equals to x squared. And then we have a point 2 and 4. But the question says that we need to find the equation of the tangent and equation of the normal at this point. That means that this point given here is the point of tangency. That is the point on the curve where the tangent touches the curve. And at that same point, we have the normal, which is perpendicular to the curve at, which is perpendicular to the tangent at that point. Remember, the normal is never perpendicular to the curve. So please take note. Now, from here, how do we get the equation of the tangent? It has to start with the tangent. For us to get the equation of the tangent, it means we need the gradient of the tangent. And for us to get the gradient of the tangent, we need the gradient of the curve at the point of tangency. And now for us to get the gradient of the curve at this point, we need to get the gradient function of the curve at any point. That means we need to differentiate the given function of the curve. Thus, dy dx equals to 2x after differentiating it. So, this is the gradient function of the curve. Now, when we have the gradient function of the curve, it means we can find the gradient of the curve at the given point. So at the point 2 and 4, we can find the gradient of the curve. That means dy dx at the point of tangency 2 and 4 equals to, we substitute for x here, where we know that this is x, this is y. That means we shall have 2 times x, which is 2. This here now gives us 4. Okay? So 4 is the gradient of the tangent to the circle. Why are we saying that 4 is the gradient of the tangent? Now, if you look here, we have said that this 4 is the gradient of the curve at the point of tangency. But at the point of tangency, the gradient of the curve is the same as the gradient of the tangent. So, therefore, gradient of the tangent is 4. Why? Because at the point of tangency, the gradient of the curve is the same as the gradient of the tangent. Now, we have the gradient of the tangent and we have the point of tangency. Remember, this point is being shared by the curve and the tangent. So, the tangent also passes through the point 2 and 4. So, what do? We have the gradient of the tangent and we have one point on the tangent. So we can use that point to find the equation of the tangent. So for us to get the equation of the tangent, we have one point on the tangent, that is 2 and 4. And we have the gradient of the tangent m, which is 4. Then we call it m, which is 4. Now the tangent is a line, so we can use the formula for equation to a line given by y equals to mx plus c, where m is the gradient. This is x, this is y. So we can find c, where we say that c is the y-intercept. So our y is 4 equals to our m is 4 times x is 2 plus c. That means here our c equals to negative 4. In this case, our c is negative 4. Now, after getting c, then now the equation becomes, we substitute for y equals to What is n? N is 4. We attach x plus c, and c is a negative 4. So this is the equation of the tangent to the circle, to the curve at the point 2 and 4. I have just finished covering circles, so I'm confusing circles and curves because it is the same concept. Now, after getting the equation of the tangent, that means we need now to find the equation of the normal. What do we know already? We know that the normal is perpendicular to the tangent. That is what we know. But the normal is perpendicular to the tangent. That means these are perpendicular lines. They are perpendicular lines. And what do we know about perpendicular lines? We know that for two perpendicular lines, the product of their gradients is -1. So therefore, the product of the gradient of the first line m1 and the second line m2 equals to -1. So let me call the gradient of the tangent m1, so that this is m1. So m1 is 4. m1 is 4. So here I'm going to say 4 m2 equals to -1. Therefore, our m2 is -1 out of 4. m2 now is the gradient of the normal. m2 is now the gradient of the normal. Now, remember, the normal is passing through the same point. Okay, that means this same point 2 and 4, it has three things passing through it. One, the curve is passing through this point, the tangent is passing through that point, and the normal also passes through that point, because I sketched something like this. You see, so this is the point 2 and 4. So we have the curve, it passes there, we have the normal, we have the tangent, and we have the normal. So this same point is being shared by the three, that is the curve, the tangent, and the normal. So if we know the gradient of the normal, and we know one point through which the normal passes, and we know that the normal is a line, that means we can find the equation of the normal. So at this point where the normal passes 2 and 4, we can find the equation of the normal, which is a line. So we can say y equals to mx plus c, where this is now our m in this case. Our m is -1 out of 4. Putting m2 here and m1 there was just to distinguish between the two gradients, but in the end they are gradients of two different lines. So this is x, this is y. Then we substitute so that we can get c, because we know that c is y-intercept. This is the point on the y-axis where the normal in this case touches the y-axis. So we're going to say y is 4 equals to m. m is -1 out of 4 times x, x is 2 plus c. Then from here, we make c the subject of the formula. So -1 divided by 4 times 2. If I take it there, it becomes positive. So 4 minus answer, 4 plus answer actually. It becomes positive. So 4 plus 0.5, 3.5. So I'm getting my c as 7 out of 2, or simply 3.5. I hope there is no mistake here. Yes, it becomes positive. So after getting c, then you just come and use the equation of the circle of a line, please. Use the equation of the line, substitute for m and c only, with y and x. Therefore, y equals to m. m is -1 out of 4. We leave x plus c, so we say 7 out of 2.